Okay, in this lecture video, we're going to talk about an easier way to look at relative amounts of hydronium and hydroxide ion concentration so that we can tell whether or not something is acidic or basic. And to do that, we're going to use the pH scale. So the pH scale ranges from 0 to 14, with 7 being in the middle. Anything greater than 7 then is considered a basic solution, and anything with a pH less than 7 is considered to be acidic. And so how do we get to the pH of a particular solution? Well, it is the negative log base 10 of the concentration of the hydronium ions that are floating around. And these concentration values, again, are measured in molarity. And the pH itself is a unitless quantity. Okay, so to convert between a hydronium ion concentration and the pH scale, you take the negative log of the value. So let's look at some examples. So let's say that the concentration of hydronium ion in coffee is 1.0 times 10 to the minus fifth molar. Then we would calculate pH from that and say pH is the negative log base 10 of 1.0 times 10 to the minus 5. And if you took the pH of that, you would get the pH equal to 5. Therefore, coffee is an acidic solution. You probably already knew that. Let's do another example where we're going to work backwards. Let's pH of lemon juice is 2, and we want to know what's the concentration then of hydronium ions in that solution. Well, the concentration of H3O plus, to work this problem backwards, would be the antilog of the negative pH value, so the antilog of negative 2, which is 10 to the minus 2, which is 1.0 times 10 to the minus 2 molar. And we will practice in class taking logs and antilogs on our calculators. So then we could also calculate a pOH value, because we can convert between pH and pOH, which would be the negative log of the concentration of the hydroxide ion. And the pOH is simply 14 minus whatever the pH value is. So there are two scales actually that we work in. There's a pH and a pOH, but most often we work with pH when we're just talking about whether or not a substance is acidic or basic. So let's take a look at one more example. We'll look at an example of a strong acid and how we figure out the pH of that particular solution. So let's say we want to know the pH of a 0.1 molar solution of hydrochloric acid that we have. So hydrochloric acid is a strong acid, which means it completely breaks down. It completely ionizes into H plus and Cl minus. So all of the 0.1 molar HCl that we started with, since it's a 1-to-1 ratio, there's 1 H plus for every 1 HCl that we have, we know that the concentration of H plus that gets produced when the HCl ionizes is also 0.1 molar, as is the concentration of the chloride anion. So if we want to know the pH of a 0.1 molar HCl solution, we would say the pH is equal to the negative log of 0.1, because that's the concentration of the H plus specifically. And if you do that math, you get that the pH is about 1. And hydrochloric acid is the acid in your stomach, and your stomach pH is about 1.2 based on the concentration of HCl that we have. Now note, this only works for strong acids, ones that have completely broken down and released all of their H pluses. However, we also know that there are weak acids out there. Actually, most acids are weak. So for example, acetic acid, the acid in vinegar, is the one that we talk about the most, CH3CO2H. We know that as an acid, it releases H+. In fact, this is the one that got released. That's that one. And then you have the conjugate base, which is everything that's left over. That's acetate. But what we know is that most of the molecules stay together. So even if we had, for example, a 1 molar solution of acetic acid, that does not mean, I'm going to put a does not equal a 1 molar solution of H plus that gets produced, because not all of these H pluses here have been released. So it's not a 1-to-1 mole ratio. So you can't simply just take the negative log to calculate the concentration, or sorry, the pH, because the concentration of acetic acid here is not equal to the concentration of H plus that gets produced. And we're not really going to work on that in this class, but it's important to note that the calculation we did with hydrochloric acid on the last slide only works because it's a strong acid, and all of the H pluses, all of the acidic protons in the hydrochloric acid, get released as H pluses.